Okay, these notes are moles and mass for honors chemistry. Okay, in an equation, the coefficients, you know, those big numbers in front, represent moles. Like this 2 here. Nothing, of course, means 1, and another 2. So if you were to read this, this reads 2 moles of hydrogen plus 1 mole of oxygen yields 2 moles of water. Now, since we can't measure out moles directly, we need to convert to mass. We do this by using the molar mass of a substance. Now, the molar mass is the mass of 1 mole of any substance. 1 mole of any element is its atomic mass in grams. So right now, you guys need to pull out your periodic tables. I would like you to follow along when I do this so you can look up the masses as I go, so you know where the numbers come from. Okay, so if you look at hydrogen, underneath hydrogen says 1.01. Now, normally when we did this with the unit 3, it was 1.01 AMU, or atomic mass units. But since we're talking about a mole of hydrogen is actually 1.01 grams of hydrogen, okay? So the molar mass is 1.01 grams per mole. So for every 1 mole, we have 1.01 grams. If we had 2 moles, we'd have 2.02 grams. 3 moles, 3.03 grams. Hopefully you get the idea. Okay, to find the molar mass of a compound, you add up the molar masses of all the elements in that compound. So let's look at water. Water has 2 hydrogens and 1 oxygen. So 2 H's plus 1 oxygen. So now our hydrogens have a mass of 1.01 grams per mole, and our oxygen has 16 grams per mole. Now, 2 times 1.01. Now, if you don't have a calculator with parentheses, you actually have to do this next step, and that is 2.02 grams per mole plus 16 grams per mole. Now I can add them up on the calculator, and I get 18.02 grams per mole. Now, if you have a calculator that uses parentheses, just put in exactly as I've got it written here. 2 parenthesis 1.01 end parenthesis plus 16, and then hit equals or enter. And you will get 18.02 grams. Well, you'll get 18.02 is the number, grams per mole. So that's the molar mass of water. Okay, so every time I'm using it, I have so for every 1 mole of water, I have 18.02 grams. So remember that water that we passed around in class? That was 18.02 grams of water. That's how I knew how much to put in there, because I knew that 1 mole of water weighs 18.02 grams. Okay, let's try some more. So let's look at C3H8, which is propane. So there's 3 carbons and 8 hydrogens. So carbon, if you look on the periodic table, has a mass of 12.01 grams per mole. I'm only going to write 12.01 grams. And truthfully, when you guys are working out these practice problems, that's all you have to do. You don't have to put grams per mole for each one, because we're trying to calculate the mass of 1 mole. So technically it's just grams. So then we have 8 times 1.01 grams. Now, as I said, if you're not using your calculator that has parentheses, then you have to actually do the second step, which would be 36.03 grams plus 8.08 grams. But if you're using one with parentheses, you don't have to do that step. By the way, the 12.01 is carbon, and we know 1.01 is hydrogen. And we get these from the periodic table, just to make sure you know that. Okay, so 36.03 plus 8.08 is 44.11 grams per mole. That's my molar mass of propane, C3H8. Okay, let's do the next one. What is the molar mass of silver sulfate? Okay, so let's look at what we have. We have 2 silvers plus 1 sulfur plus 4 oxygens. Okay, so 2 times, now we look on the periodic table, silver is 107.87 grams, plus sulfur, which is 32.06 grams, plus oxygen, so there's 4 of those, so it's 4 times 16. And when you add them all up, it becomes 311.80 grams per mole. So that's the molar mass of silver sulfide. Okay, let's move this up a little bit so we can do this one. So what is the molar mass of copper 2 phosphate? Oh, there's a lot of stuff in this one. So we know that there's 3 coppers plus, now this 2 goes to this phosphate, but it also goes to the oxygen. Okay, so there's 3 coppers, because that 3 goes to that copper, 3 coppers, 2 phosphates, and 8 oxygens. So copper is 63.55 grams plus 2 times phosphate, which is 30.97 grams, plus 8 oxygens. Okay, so there we have 380.59 grams per mole. Now, there is one little incident that I don't have it typed out here, but we're going to go on to another one. Actually, see if I can move this up a little bit. Okay, so sometimes we have water added to it. They're called hydrates. So it's copper 2, trying to think what it is, copper 2 sulfate, so SO4, with water. So I think it's got 5 water, so 5H2O. This one is a very strange one because you're adding, but that little dot, mathematically you think, oh, that dot means multiply. It doesn't, okay? It means adding. Now, there's 2 ways to do this. We already know what water, the mass of water. So I'm going to show you that method. Otherwise, you can go back to the method we were just using, and it's no big deal. So at this point in time, I would say this has 1 copper plus 1 sulfur plus 4 oxygens plus 5 H2Os. Now, we already calculated the mass of water. In fact, it's really something you should put in your head and remember, because it will make a lot of things easier, especially when we get to the hydrates in this unit. So it's going to be, whoops, I don't need the 1. So copper has a mass of 63.55 grams plus, and then there's the sulfur. Okay, so let me look up sulfur again. Sulfur has a mass of 32.06 grams plus 4 times 16 grams. Okay, and then we know what water is. Water is 18.01 grams. So we're going to put plus 5, or 18.02 grams. Okay, now we're going to put this in our calculator. So we got 63.55 plus 32.06 plus 4 parentheses 16 end parenthesis plus 5 parenthesis 18.02 end parenthesis, and we get 249.71 grams per mole. Okay, so what this is not a times, this means plus. So just got to keep that in mind, because I know last year and the year before and actually every year, somebody out there wants to multiply it. It's not a multiplication. What this means is copper sulfate has 5 waters attached to it. So we're just going to add up the mass of 5 waters and add it to the mass of the copper 2 sulfate. Okay. Okay, so now let's go on to the actual problem. So we want to know what the mass of 1.50 moles of NaCl is. Well, obviously the first thing we've got to do, let me move this down a little bit, is find the mass of NaCl. So when you add up 1 Na and 1 Cl, so I'm going to say 1 mole of NaCl, equals 58.44 grams. We're going to use this conversion factor in our calculations. Now remember, we're using picket fences. Now this time we are using the left side of the mole bridge. Okay? Last time we used the right side, this time we're using the left side. So we're going from mass to moles. Okay, so when we look at the mole bridge, if you look at your mole bridge, when you go from mass to moles, you divide by molar mass, but if you go from moles to mass, you multiply by molar mass. Multiplying, of course, means you're putting it on top. So the first thing I'm going to do is draw my first thing I'm going to do is put it on pen, draw my little picket fence. I'm going to put 1.50 moles of NaCl, draw my little line here, extend my picket fence, and I'm going to put, this is my conversion factor, okay? So I have to put 1 mole either on bottom, top, and 58.54 grams on bottom or top. Now, the mole bridge says to multiply by molar mass. Well, the molar mass is the 58.44 grams. So I'm going to put that on top, and I'm going to put grams of NaCl, because you still have to put the grams of what? And then 1 mole of NaCl. And if you don't want to look at the mole bridge, you really don't have to. You know to put the 1 mole of NaCl on bottom because you got to cross off the moles of NaCl that's already on top. So we cross that out, and when you do the multiplication, of course, 1.50 times 58.44 divided by 1 is 87.7 grams of NaCl. So if I have 1.5 moles of NaCl, I have 87.7 grams of NaCl. Now notice I've got 3 sig figs in my answer. That's because I had 3 sig figs to start. We're going to try and use sig figs throughout this unit. If it looks like we're having too many issues with it, we won't. But one of the things that I do like to do is keep to 3 if I can, sometimes 4. So keep that in mind. Sometimes it's even 2, but 2 is a little too little. I like to keep to 3. Okay, so let's go on to the next one. Okay, next, what is the mass of 0.587 moles of ammonium sulfide? Okay, so we still need to calculate. The first thing we need to do is calculate the mass of NH4. Oops. Well, my pen doesn't like me today. So when you calculate the molar mass, it's, of course, 2 NH4, or 2 N's, 8 H's, and 1 S. So it's 2 N's, 8 H's, and 1 S. When you add that up, you get 68.16 grams of NH4 2S, ammonium sulfide. Okay, so we're going to put that in our picket fence. So we're going to start out with 0.587 moles of NH4 2S. Now guys, when you do the quiz or the practice problems, please do not get lazy. Do not put the moles of the substance in there. I will count off, okay? When we get to the next unit, you're going to have to. Otherwise, you'll get confused what substance you're dealing with, because you're going to go from one substance to another. So you have to get in the habit of putting the number. So every picket fence should have a number, a unit, and a substance. Number, unit, substance. So just remember that. In fact, it's going to be on the board. Number, unit, substance. It should be on the board already, come to think of it. But number, unit, substance. Okay. So next we're going to do 68.16 grams of NH4 2S, 1 mole of NH4 2S. Moles of my substance cancel out. So now I have 0.587 times 68.16 divided by 1. And when you do that calculation, it comes out to 40.0 grams of NH4 2S. Okay? So let's try another one. Okay, this time we want to know how many moles and 12.5 grams of CO2. So 1 mole of CO2, so I'm going to add up 1 C plus 2 O's, and I get 44.01 grams. Okay, so I'm going to start out with 12.5 grams of CO2. Now if you look at the mole bridge, going from mass to moles, because grams is mass, you've got to divide by molar mass. That means the molar mass is going on bottom. So I'm going to put 44.01 grams of CO2 with my 1 mole of CO2 on top. Now, grams of CO2 are going to cancel out because one's on top and one's on bottom. Remember, they have to be diagonal to cancel out. So now I have 12.5 divided by 44.01. By the way, you don't have to do this middle step. I'm just doing it for those of you that really need to see the multiplication or the division. But if you just want to put in your calculator 12.5 divided by 44.01, okay, you can skip this step. You don't have to put that one in there. Okay, so 12.5 divided by 44.01 is 0.284 moles of CO2. Okay? Okay, let's go on to the next one. How many moles in 735 grams of silver nitrate? Okay, so 1 mole, oops, keep doing that, 1 mole of AgNO3 is equal to, handy dandy calculator here, 169.88 grams. Okay, so this is what we're going to use. So now we're going to start with 735 grams of AgNO3. Because it's division, I'm going to put my 169.88, let's put the period there, grams of AgNO3 on bottom with my 1 mole of AgNO3 on top. Grams of AgNO3 cancel, and I'm going to skip the middle step. I think you guys know it by now. So you're going to take 735 divided by 169.88, and you get 4.33 moles of AgNO3. Okay, so that's it for tonight's notes. Tomorrow in class we'll do a warm-up, and then we'll do 7.3 to 7.5. So if you have any questions, it's a good time to ask me tomorrow. So I guess I will see you tomorrow. Bye.